while the design starts at the initial stages, it's better that the structural engineer be involved along with the design process, which will help the architect as well as the because as I discussed, the shape, the height, the offsets, we can all judiciously mix together and come to a good conclusion. Now, in the second slide, one very typical problem that we face is that a wardrobe, a window, a toilet, which is very common in a bed on the side of the bedroom. Now you see there we have to put a beam, and we cannot put any vertical member there. Now again, I understand again that these are the essentialities of the design, but if this can be judiciously designed from the very beginning, so if we can shift the, say for example, the cupboard on the other side, then probably we can have some increase the wall, so the structure is also stable and also efficient enough. So there, if we do these things, then we can have a saving. Now in the drawing it below, what we have tried, you remember Vivek was saying about the parking grid. Now between me and Vivek, we were just trying to say that see that how an efficient parking grid can be transformed into a living grid. Like, see, for example, we have 2 bedrooms adjacent to each other, and then the 5.5 for the double height car parking has been mechanical car parking has been provided, and with a little increase in the height, we can provide 3 cars. You see, and with this, and we don't have to transfer anything, and the entire grid remains the same. So these are the things which we, I would say that if these are implemented from the very beginning, then at the end of the day, the saving of 4% is achievable. Next slide, please. Another thing me and Vivek was discussing regarding the intelligent use of the facade. You see, it's very common these days that we have, because chargers are not provided over the windows. So what we do is a double wall. There is a wall inside, and you have a wall outside. And between the 2 walls, there is a fin. So there is a double wall. We need to plaster that. We need to erect. Say, for example, if you're using aluminum shuttering, then the RCC wall is erected, and then you come back with the brickwork. Then you see cracks there between the concrete and this thing. So your pain is going on. So me and Vivek was thinking that with the aesthetic, functionality, cost and maintainability point of view, is it a possibility that we have a projection of about 600 all around the building, and wherever there is a window, we provide RCC fins. These are all RCCs which are easily doable in these days with your aluminum shuttering. So the maintenance is easy. You don't see the cracks, and you know that finally there is we can save about 40% of the facade cost. Next slide, please. Now, a case study, you know, as a right friend from one of our live project, we did while discussing the right framing. See, the left hand, a standalone building, is a G+7. It's a it's not compared to the today's style. It's not a challenging one also. A G+7 building, we framed it out with a column beam normal structure. It's nothing, we are all used to this. And to the right, that same building, in the same plan, we have done with an RCC wall building. There is no brick wall inside. All are RCC one. The red ones are load-bearing RCC walls, and the green ones are your non-load-bearing walls. Now, we have to be very judicious in applying what frame we are using what. For example, if there is a standalone building, 1 building or 2 building, and we are using aluminum shuttering with shear wall like this, then well, you will not get the efficiency of the cost that you are looking for. So there, the column beam structure that we are used to it should be the right apt structural system for this. Now, the moment you go for a 10, 12, same number of buildings, even 6, 7 number of buildings, and you for these buildings, you can understand these deliveries have a time challenge to it also. So with the aluminum shuttering, this thing, and with the RCC wall system, this can be very cost effective, and at the end of the day, and the time saving also. You know, with mass housing, if you go for this standalone type of structure, you go on doing it. But with this aluminum shuttering and RCC wall, you will save time, of course, cost, and the quality, of course, will be much higher, and we can save to the tune of about 6%. Next slide. Now here I'm showing two types of framing system. Again, framing in the right framing system. You know, the top one is a more affordable sector unit, and the lower one is a very luxurious apartment. Now, in both the cases, we used aluminum shuttering was used, and basically it's an RCC wall building. But in the lower one, you can see in the upper one we have used all RCC. Everything is RCC. Even the red ones are non-load bearing RCC walls. Blue ones are, of course, load bearing RCC walls. But in the flat below, the red ones are all AAC blocks. Now here we added the flexibility with the high-end, high-end residents. There are changes, and if you go for an RCC wall, then you go on changing because of the demand of the client. So that's the flexibility we have added to this. So you need not redo, redo all these things. So so with the right framing system, we can save to the tune of 4% without redoing things. Now again, right framing. See, this is very interesting project that will have a case study. It has a dual effect, I'll tell you. This is a commercial building, a part of a commercial building, and the system that we have followed is not the normal system that you will see is the flat slab capital there. Normally we see in a commercial building because the heights are restricted. What we use is a steel concrete frame with a steel runners. There's a mechanized sort of steel runners that has been manufactured, which is called the speed floor, and we have used it very effectively. I tell you why. The concrete thickness of the slab has been reduced drastically. It is 75 to 100, not more than that. So you can imagine the amount of concrete that has been reduced in the entire building, and to the advantage that we got, the column with the reduction in the concrete, huge concrete we have reduced. The reduction in the concrete has resulted in reducing the dead weight of the structure, and thereby we saved in the foundation cost also. So that's what I'm trying to highlight, is that the right framing system should be applied to the right project. So that's what Vivek again said. I would remind you all that optimize. We should do the 3 options. What he said. This one will cost you. This one will cost you. This one will cost you. And we'll give you our recommendation, which we would like to go for this thing. So that's the options. I also agree that options should be very important. Next slide. Now coming back to this project. We have shown you the right framing. This is a small case study that I have tried to do. You know, while doing this is a basement plus ground plus 2 basement plus ground plus 7-story building, commercial building. As I said as I described in the earlier slide, that we reduced the dead weight of the building, and with a 2 basement, even in a poor soil like this. In Rajarhat area, we could do the foundation without piling. This construction is going on, and the piling cost and the time of piling has been reduced, and at the same time the foundation and the structure, we can I think we have saved more than 8%, 10%, more than 10%, I think, in the whole project. So this is a very important project. What I would like to, things have come up very nicely there, I tell you. Now, one thing that I would, when I started in a note, that still is not the only parameter that we should all look into. And to our misery is the soil in Calcutta is not conducive to a cost-effective foundation system. We have studied the cost of the foundations in a general in Calcutta. It comes to about 30 to 35% of your total structural cost, and compared to the other places, we get about 20 to 25%. So already we start a project with a 10 to 15% more than the other places. Now there are pockets, good pockets in the entire city, in Alipur, in Baripur, in Taliganj, there are pockets in Newtown. You can see good soil, pockets of good soil. Now, this is a soil profile which is a general soil profile. As you can see, that we start with a very soft, and there in between we have the worst thing in our life is the decomposed wood part, which will not allow us in any way to go for a shallow foundation, that is a rough foundation or isolated pocket foundation or even street foundations, unless we do something, the case study that I have shown you, that we do something where the load of the structure is almost equivalent to the amount of soil that has been displaced. So there is no additional load into the whole structure. Now, so that's what I'm trying to say, that in the Calcutta context, instead of we fight with the steel consumption, because see these days the sophistication in the analysis, computer packages, and the codal provisions that is there, that we do not have too much of a play or margin to play with the steel. But with the right iterations, with the right thinking of the soil, with the right investigation of the soil, we can get into a foundation which can get you even a 10%, 5 to 10% of the saving in the foundation, which I think is what doing it, what spending the time there. I would suggest that. Now, in order to do this, the right foundation and the cost-effective foundation, what I would suggest is a very, very detailed geotechnical survey with the number of boreholes. We should get a gridded boreholes, right depth, right undisturbed sample, collection of the right undisturbed samples. Study see, for example, what I do, it's my personal thing. Whenever I get I hear that the geotechnical investigator is there already in the field, I ask them to send the raw data from the site immediately, so that I can frame up my mind that what are the tests that need to be done, what are the samples that need to be done, what depth you should go to get your foundation system. Now, so one suggestion that I also get to my geotechnical investigator friends also, the recommendations should be done in consultation with the structural engineer. I would just give you an example of one project in Moddamgram, where we got sand from the right of from 5 meters, and you know that with a little deeper basement, we could erect a residential building with basement plus 11 without a pipe. So initially the geotechnical investigator was, there was some, he was not too happy with the things. But I just went on discussing with him, and finally it was done there. Now again, the pile capacities. Pile capacities also are a little, underestimated because there is a back of the mind that whether the construction of the piles will be okay or not. Now we have to give them the confidence that, well, the pile will be done. So please take the end bearing and give us the right pile capacities, and which shall be, of course, authenticated by the initial load test, which is a must in any circumstances. Now, the adaptation of the right foundation system is also very important, which we should always take care. Now, coming to a very interesting case study, we did a peer review for this project. Is a mixed-use project in Rajarhat. There you could see there are low-rise, high-rise, tall, slender structures, all in the same basement. Now, initially it was all proposed to have pile foundation. Now, with a 9 meters, 10 meters down with 2 basement, see what we have used all sorts of foundation. Like in a common basement, the lower floors, we didn't have any piles at all. The higher ones, we use the pile raft system, and the taller ones, only pile system. And it's the same basement. What we did during the construction, we left some gaps apart so that, if there is any differential settlement, which will take care. And probably, and as a general principle, there is not going to do any differential settlement, because all the loads there are all, we have made the foundation system in such that the stresses are same. So we saved a considerable amount, and the next slide will show you that about 118 rupees per square feet has been saved, and this is a live project. I tell you, this is a live project that has been done already. So what I would say as a percentage wise, there is an 8% saving. Similarly, if there is another project where, as I earlier said, that as per the geotechnical engineer, some pile shaft was proposed, and we recommended that if the reduction of the pile shaft can be done, and it's put into the sandy layer, and to our surprise, that we got the same capacity with the end bearing that I told you that is normally getting ignored these days. But with the end bearing, we got the same capacity, and a 7 meter of your pile length has been saved, which is about a 5% of your total cost. Now I think with this I hand over to Vivek. I'll come back again because I think
sure. We are doing this on and off for you to make it. That was wonderful. The amount of money that goes under the earth is very important, and we often think everything on top of the earth and the building as a design, but the amount of homework that we need to do below the earth, and with the geotech assessment, we can actually do a considerable saving, and that is so very important. It's not just about reducing pile depth, but it's about understanding various combinations which can be done in 2 types or 3 types of regular foundation systems. But it's very important that we actually go with a geotech assessment, and the structural engineer and as well as the architects go hand in hand to understand this one. Well, to take it further, planning and design today, it's very vital that we're talking about BIM, and often we think that BIM is about understanding clash detection. Often the people, maximum the guy does it, okay, I'll do a clash detection about building information modeling will be helping us. But today, it's much more. It's not just about BOQ, but it is furtherance of a building into the operations. Real estate does not just mean make and sell off. It also often means operate. And most of the people who are there right now as viewers or in the business know the meaning of leasing and operating a building. So everything, BIM often helps in a simple manner of actually actuating workshop fabrication, in initiating the thinking for prefabrication. So we should, 100% of these buildings today If it's a residential, I would say please do it also. Don't, because it's hardly a cost that you're putting in, but the amount of saving that you do is, it's much more. I'm not going into details of it reason because we have a paucity of time of what we're continuing. But having said this one, if you really want to get your estimates perfected, we have to work on this. If we actually have to accommodate changes in design, we have to have a live recording of that, right estimates and right kind of detailing to layer. So we would need a BIM as a continuous process rather than one of the process which just comes in. It is a facilitator consultancy rather than the end consultancy. And most interesting, important part is between operation and maintenance of the building is also a continuation of this thing. So this is a slide which I thought that, you know, we would actually understand that the design, the BIM actually design percentage using BIM is a percentage, but we since operation and maintenance ultimately the business advantage when it comes, when you know that your pipes have gone like this, when it as-built drawings, your details are clear, you can actually collaborate and corroborate, include your BIM model into the operation model. So now you have got technology in which you actually include it, and you can have real-time data in terms of operation. So it's no more like the information is just coming from the system or the technology that you put in terms of understanding the parameters of energy consumption, but how the lens, which lens, suppose you need to program repair and maintenance, you know that this is the installation, this is being more used, more runoff, this is having more frequency vibration, I need to take this care of pipe and then further 3 more bends. So you can actually estimate this entire sequence or length of services. Though for this presentation, we have actually excluded the MEP because it will be too lengthy. But what is more important to understand is almost 70% of contractors have understood that in projects can actually come from BIM. And the owners, almost like 50% of the owners, right from the initial stage to the others. Consultants, of course, we all know that almost designers and architects know how important the need of BIM is happening. Okay, we were coordinating, and while you include the BIM and coordination, it's another activity of coordination. No, it's furtherance into operation and maintenance. So this actually, including it the day one into your planning, especially for the mixed-use designs, and taking it further into the construction field, is so very important in terms of checking, because you can actually further a model. In future, you would be actually, everybody would be using a very handy mobile with a BIM model. You can just, every supervisor knows that, okay, this detail would go like this. You will not look at the design, the drawing will come here. Actually, it's being done today. So this, we have to make the process so simpler, then we would actually use the BIM effectively. And if you tomorrow into operations, your system change, if you want to change a system, or plug and play with your assembly line, tomorrow if you want to change an HVAC to an upgraded system, you want to know what has been there. What are the pipelines already there? What are the walls there? Which needs to change there? Everything can be substantiated. And to change this wall, I actually need to change a lot of stuff. You can actually keep the way it is, and it's better to put a secondary one. So all this thought can actually come down on a plate and assess your cost to maintenance very effectively. Well, coming back to the second part of it, we've all talked planning. We'll go a little more faster between me and Utpal to basically cover the slides faster. So the detailing becomes very important, and what important is evaluating the details. Often detail is something left and never discovered or never discussed. I think it's a very important process that we actually have a proper detailed workshops, because we usually conduct these workshops, and I find ourselves becoming much more logically aware and intelligently participating only in these workshops. You have to repeat multiple process. Now what happens is, in a construction process, we often have a process made and we have to reduce number of tasks at site. A right detailing, even a lightweight railing, which can be used and lifted by just 2 people, made in the workshop, just comes there and can be snuck down in RCC, is a better detailing rather than keeping the MS extruded from prior to the casting and then try to do so multiple tasks and ultimately not being able to achieve the finishing. Easy handling on site. Off-site job work should be an optimized manpower. Resilient quality. Sometimes the detailing that we do, when it is done at site, it is prone to such other issues that come on site. The multiple layers of work that come, they spoil the finishing. What is a resilient way of quality? and minimal intrusion. If something is finished, let the second detail come with a minimal intrusion. Intrusive details are the least now. And what is more important is conducting these workshops and execute the pre-construction mock-ups. Please, importantly, it's my request and our understanding that designs which do not or process of construction which do not habitate or promote mock-ups approval actually go for a long change or a delay, or qualitatively they go poor. Around 17%. Smart detailing saves time. Your time can save. Time today is money. 17% is a huge time, and we have to give importance to how this is done on time, and especially when you want to keep the quality aspect of your design. A simple example, I cannot cover everything, but simple thing. We often are not very clear about RCC. We still use timber, then do all this other works of polishing, preparing, then we have some issues of scrap and cutting. We can go for an RCC frame, a precast concrete steam cured a frame with a proper detail for inbuilt detail for a hinge setup, and you can save 50-60% of your costing just in building frames. So the same door can be put up there, but the frames are very important because a part of the thing just got the timber doesn't have well detailed out in terms of it needs a huge amount of quality and time to get the relative look and feel of finishing. Well handled. So a simple thought, we have to start thinking, and for this we need not, this is a green objective. So today not only save cost, but you become green. Do not use all the other issues of termite, borer, all these things. Things like, sometimes we still have people insisting that we need sunken slabs for this thing. You don't need to sunken slab or even a folded slab. You can just actually work with a 2-inch drop, non-structural drop can actually be obtained, and you can actually handle a thing. In this case, a lot of saving in when the waterproofing cost, which comes down as a drop here, containment and other structural savings, almost 8-12% of the costs can come down simple just by having a trim of paint 50 mm, which takes care of kinds of tile drops inside. Interesting case study. We analyzed our errors, and we all have life like this. So what we actually analyzed in saying that in most of the duplexes have staircases. We just take a duplex staircases. You make a detailing of a staircase in which you do RCC, put Italian marble, put glass, balustrade, and kind of thing. Make it a heavyweight stuff. It not only consumes 50% more time, 25% more time, 60% higher complaint, because there will be a dissatisfaction factor, which will go into people saying, "Ye to achhi nahi thi. This is not the right way to do it. The Italian marble is not the right kind of matching," because you know that everything cannot be standardized in terms of natural resources. A lot of complaints. Whereas if you just go for an MS, which can be nicely welded, a cropper, no glass, nothing, MS, which gets 50%, 2 or 3 panels get installed there. With an oxide painting, and then final coat of painting can be done, and finally when everything finishes, you come and put the threads, timber threads at the edge. It looks so sophisticated and clean detailing. So things like this, I will just analyze the 35% more cheaper would be a pleasant timber alternative, and that is and that's more fashionable, more durable, and less prone to complaints. You add up in creating a wonderful asset with a lot of saving. It is no compromise on the quality, but a little more thought in the process engineering that we need to build in detailing. A simple glazing. Sometimes we try to say that we want to achieve a 50% or a 60% glazing opening. So between 1/3 and 50%, you might actually be spending a lot of cost. These are the things which people often do. But sliding is always sufficient than a casement that we know. A casement window, for example, when it comes to glazing detailing, we should always detail out and beyond the 2 casement, it becomes expensive, and beyond an 8 feet 2 sliding becomes expensive. Not only expensive in terms of section, but also in terms of sometimes the optimization in terms of glass thickness and the section thickness with the resistance, wind and operational ease and everything. There is a technology which has to be analyzed, and these are the points that we really need to do. I request a couple of slides on detailing with on this.
Yeah, we are running short of time, I understand. There's a very interesting detail that we have thought of for your roof. Now, we experience that you go on doing the waterproofing in your roof, and at the end of the day, it fails, and again the screed is put into it, and again a layer of waterproofing, and again a layer of screeding on top of it. So you go on, and still your roof is leaking. So, you know what I have found out, the root reason of this is there are micro cracks on the roof slab itself. So what I propose is increase the slab thickness whatever required by 10 to 15 millimeter more, and have slope itself in the concrete roof slab with a flat bottom, just you create a reach and then slope down to the two sides, and provide a reinforcement at the the span or at the top of the span with a very light reinforcement. So there are always a two layer of reinforcement, very light reinforcement I will say, and the concrete be modified with a little bit of polymer into it. So what I'm trying to do is restrict the shrinkage cracks by using the reinforcement, and the concrete by using this polymer. We are making it a little impervious. So at the end of, and the slope is already there, so you need not do a huge thickness of your street and etc. So this, it gives you a huge amount of saving, and at the end of the day, time also, because you go on doing it. Now, coming to this AFC block, I think we are finding a lot of difficulties, facing a lot of difficulties in, and there are cracks that are being seen. Now, one thing that I would like you to do is, every third layer we have a mortar with a light 3 mm reinforcement. And the most important is why in Calcutta we are facing this crack, as I have found out, that the density, this is the most important thing I tell you, the density of the AFC block that are being sent to us, is supplied to us, are much low, 450, 500, at times maybe 600, but 450, 500, 600 are bound to crack and bound to get wasted. So I would say, there should be a meeting between all the suppliers there, that boss, you need to supply us of a density of 700 kg per meter cube, and with some sort of we are preparing some details which we will be sending it to the codal provisions also, codal committee also, that simple detail with just mortar strengthening, which will help you out and cost effective also. So don't worry about that the AFC block is not useful. It is useful. It reduces the load of the building to a great extent, and thereby the foundation cost. But yes, the density has to be looked into. Now, yeah, Vivek again.
Yeah. So when we come to the material and finishing, often there are more solutions that we have, but there's something called where to use what material and why is that we need to understand. Is a simple comparison of a staircase. You know, when you have a staircase, today we have a complete RCC casted building, 3/4 concrete going everywhere. Why do we need to put quota there? So when we are, okay, while I'm saying quota as a stone, quota can also be used in the public areas. And we often clad our fire staircase and staircase with the stone. You need not do the high rises, need not have the fire staircase, not often used every day. You've got elevators there. You can actually do an epoxy paint, and that would be good enough. And even if it goes a little more ruggy over the years, that's pretty good enough to go. You may make a civil parapet wall and not do this MS railing altogether, and do maintain with paint and everything together. Even the windows can be converted into louver system. RCC precast louver, this just allows it to ventilate, complies to the fire rules, and also for residential essentially. And this is general, just a material and objective comparison. You can almost save 25–30% on the staircase finishing costing. Toilet, we have a set system. 2400 tak hame cladding karni hai. Now that is something 2400 tak everybody needs to clad. You don't need, because toilet today the paints are good enough to take care of your not to get worn out by the steam or the moisture. You can actually get rid of the application in terms of a tile to a huge amount of surface area. Keep your tile limited to 1200, and actually we all need to evolve this detail. The market is not about LIG, MIG or HIG. It's about sensitivity and good design. The fantastic paint, just do that. Keep it to a turn, and only the shower can have that full tile system, and rest is all taken care by the glass. And we can actually 30 to 35% of toilet finishes can save a cost. And it's all about the great combination and great detailing in terms of ceiling trim and the trim just above your tile, which can actually help you to gain a lot of advantage. Well, false ceilings are a good amount of nuisance, and we are completely taken by there will be a false ceiling. Let's get rid of the false ceiling. We got rid of, you have got rid of false ceilings in offices, which are public places, and great aesthetics. In residentials, as you can see in the slide, we can get rid of false ceiling in common area. It is, and do not think it is a good design always. It is not a wrong design. It's a brilliant design because the services now can be laid everywhere. You can tag them, hold them, suspend them, very clean lines, and that looks fantastic. You can service them and attend them. And even come to a system of cast in situ aggregate flooring, not mosaic or terrazzo, aggregate flooring. Sometimes people do the slab with an extra cover, grind them to finish. And or else just you can do a screed and then grind them to a finish. This actually can help us 25% of your common area costs. That's a certain amount of saving that you see. In technology, a couple of slides I want Utpal to take on this. Utpal, to you in terms of technology.
Yeah.